All right, our last video in 7.1 is just a few quick examples of maybe how we can apply function notation in certain areas. If you recall, the area of a circle is pi r squared. So we know that the formula for area of a circle, area equals pi r squared. We can use that formula just like it is, or we can actually write it using function notation. Maybe we can write it as the area, depending on what the radius is, a of r is equal to pi r squared. That means my input is radius, whatever my radius is. My output, once I plug in whatever the radius is, I can figure out what the area is of my circle. So I can kind of write this in function notation instead. Here's an example. The function a, described by a of r equals pi r squared, gives you the area of a circle with radius r. Find the area of a circle when the radius is 4. So instead of just saying a equals pi r squared, I can say a of 4, meaning my radius is 4. I can plug in a 4 wherever I see that r, my radius. I can square it, and I can say that my area, when my radius is 4, is really 16 pi centimeters squared. So what would this mean? Yeah, that would mean find the area when the radius is 2. So make sure you just understand that function notation in different contexts. All right, another one that they give us in this section is looking at a graph and evaluating the graph, kind of using the graph to estimate some values. It asks us in example number 7 to estimate the number of people that visited Disneyland in 2004 and predict the number of people who will visit the park in 2009. So this is an old example. The Disneyland population in a year is given in this graph. We'll list on the bottom a couple of the different years, and on the y-axis, it gives you the number of people visiting Disneyland in hundreds of thousands. Ooh. All right, the first one asks us to estimate the number of people that visited in 2004. So on your graph, you're going to find 2004. You're going to kind of follow it up. We should only get one value, right, of how many people visited Disneyland in that year. When you follow it up, you're just going to estimate, and that's all it asks you to do. It doesn't have to be perfect. It looks like to me it's a little bit above 80, maybe not quite in between, so not quite 90. Maybe you said approximately 82-ish. But remember, it's not just 82 people. It's 8,200,000 people visited Disneyland in 2004. That's 8,200,000. That's where I got all those zeros from, people. Really, that means 8,200,000 people approximately visited Disneyland in 2004. Whew. All right, so if the graph was cut off, could you use the graph to estimate what's going to happen in 2009? Your input is 2009. Your output should only be one number. This is still a function, right? And so if I'm kind of using this graph to estimate, maybe it goes up a little bit over here in 2009. I would say approximately 120, right? Remember 120, oh, did I mess up here? Shouldn't this have another 0 on it? Let's see, 120, 100,000 people? So it looks like 12 million people. So I missed a 0 there. So 100, that gives you 2 zeros. 1,000, that's 3 more zeros. That's 12 million people are estimated to visit Disneyland in 2009. Whew. All right, make sure you can go ahead and read a graph and use it to estimate. Make sure that you can use and apply function notation depending on the context, and just make sure that you're kind of comfortable with that format.